Hello data folks, welcome back to another exciting video in our DBT series. In our previous session, we explored the powerful features of DBT, including sources, seeds, and analyses. Today, we're going to shift our focus toward tests, another critical aspect of DBT. Data serves as the lifeblood of any organization. It fuels decision-making processes across various business functions. Therefore, ensuring data quality is absolutely crucial. DBT tests play an important role in maintaining data accuracy and reliability. Within DBT, there are two primary types of tests: singular tests and generic tests. One of the simplest ways to define a test is by writing a SQL query that identifies failing records. In this scenario, the business requirement specifies that the ship date should always come after the order date. Therefore, the test SQL is designed to identify records where this condition is not met. These tests are commonly known as singular tests as they are created to serve a single model. They cannot be reused across multiple models because the table name and column names are hard-coded. Let's consider another example. This test query identifies records where the email column in the customer table is empty. It's possible that we might need to implement a similar empty string check across multiple tables and columns. DBT supports the dry coding principle, which means do not repeat yourself. Therefore, it's not recommended to write this test multiple times. Instead, we can parameterize the model name and column name. By doing so, this test can be reused and applied across multiple models and columns, and these types of tests are known as generic tests. DBT comes with 4 pre-built generic tests. They can be directly applied to your models without the need to explicitly define the logic. Now, let's put all of this into action. Consider our existing orders fact model. Suppose the business expectation is that all records should have positive revenue. If there are any orders with negative revenue, the test should fail. Since this logic is specific to the model, we can create a singular test for it. Please create a new .sql file within the tests folder. Write a SQL query that identifies the failing records. Once done, you can trigger the DBT test command to validate the test results. The test has successfully passed, confirming that the orders fact table, loaded by our DBT orders fact model, does not contain any records with negative revenue. For the purpose of this demonstration, let's update 2 of our orders to have negative values. Now, back in DBT, let's run the DBT test command again. This time, the test has failed, and it also displays the number of records that didn't pass this test case. Just like with other DBT commands, you can access additional details about the execution by checking your log path. This includes the exact select SQL that was triggered as part of this testing. Moving on, let's proceed with setting up a generic test. There are 2 places where we can define this test logic, either within the macro folder or by creating a generic subfolder inside the test folder. Once set up, we can apply this generic test to any column in any model. To maintain better organization, let's create a separate YAML file for this. You can name it as desired. The following code block tests the email field in the customer's model to ensure that it doesn't contain any empty values. As mentioned before, generic tests are reusable, allowing us to apply it to any column in any model, where we want to ensure that the text field is not empty. In the same YAML file, we can also configure built-in generic tests. It's important to note that we don't need to explicitly define the test logic for built-in generic tests. We can directly start applying them in YAML file. Let me outline what we aim to achieve. All order ID values in the orders stage table are unique and not null. All status code values in the orders stage table are one of the specified 3 values. Lastly, a referential integrity check ensures that all order ID values in the order items stage table are also present in the order stage table. Please open a terminal and run the DBT test command. All my tests have passed successfully, which confirms the quality and reliability of the data transformed by the respective models. Test coverage is an essential metric in data projects. It measures the extent to which test scenarios have been tested. While this demonstration may not cover all models and columns, it's crucial to aim for higher test coverage in real-world projects by testing as many scenarios as possible according to your business requirements. Apart from models, these tests can also be applied to sources in a similar manner. This assists us in detecting data issues at an early stage in the data pipeline. Additionally, sources can also be tested for freshness, ensuring that the data was recently updated within a specified duration. If not, a warning or error is generated accordingly. This should be the column name in the source table that contains the details of the last updated timestamp. I've configured this at the global level, so it will be applied to all the sources defined in this YAML file. However, if you want to set this at the table level, you can use the same syntax in the table section that follows. The DBT source freshness command is utilized to initiate this check. In a production environment, it can be scheduled to run prior to the main models, ensuring that the data processed is consistently up to date. That's all I've for today. In our next video, we'll cover the DBT documentation features. Please do like the video and subscribe to our channel. If you've any questions or thoughts, please feel free to leave them in the comments section below. Thanks for watching.